Hello everyone and welcome to the YouTube channel of BeingACCA. This is Tushita Gupta, ACCA affiliate, and in this video we are continuing with our chapter-wise revision. This is chapter number 4 and the name of your chapter is Discounted Cash Flow Techniques. So as the name suggests, we are going to study all of the investment appraisal techniques which are discounted cash flow techniques which discount for the present, for to bring the cash flows to the present value. They discount for the fact that money loses its value as time passes. So this is what we will be studying in this chapter. Now let's get started. This chapter basically begins with a few formulae. So I'm pretty sure you would have not only heard about these things but also would have studied about these formulae in the previous class. Right. So the formula that we have learned to calculate simple interest is nothing but your principal amount multiplied by the rate of interest multiplied by the time it is taking, divided that by 100. So this is the simple formula that I'm pretty sure would have studied earlier also. Now, the other thing is that in business, usually compound interest is levied, which means interest on interest. So basically, let's suppose, talking about simple interest, had you deposited 100 rupees at a rate of 10%, then you will get 10 rupees of interest every year. Year 1 it's 10, year 2 it's 10, year 3 it's 10. But what happens with compound interest is that once you have deposited in year 0 100 rupees at the rate of 10% compound interest, what happens is in year 1 your money becomes 100 plus 10, the interest which you got during 0 to 1 year. So this interest, now the interest that you will be getting for the second year is based upon 110 instead of basing it on 100. So basically, if it's 10% of 110, you're going to get an interest of 11 in that. So 11 plus 110 and so on and so forth. Interest is going to be given to you upon the interest that gets added in the next year. This is how compound interest works. So just to put it in a formula, in your compound interest, your FV, that means the future value, that means the value that you get afterwards, is going to be the principal amount multiplied by 1 plus r over here is the rate of interest, raised to the power n means the number of periods for which you are depositing your money. Then let's suppose over here your interest rate was 10% annually. So the money was compounded annually. Now there's also a scenario where your money gets compounded every 3 months or every 6 months. So how do you find out an annual rate? So to convert that into annual terms, you have effective annual interest rate, and the formula to work out the same is nothing but 1 plus r raised to the power n minus 1. So n over here means the number of times you will get interest in 1 year. So the n over here basically stands for the number of periods, that your interest actually gets compounded in. So let's suppose if your interest is getting compounded quarterly, so n is going to be 4. If your interest is getting compounded every month, then it's going to be 12. If it's going to be compounded maybe for 2 times in a year, so then n is going to be 2. This is how the n that you put over here is going to work. Then let's talk about a concept called discounting. So whenever you have to bring your money to let's suppose you're going to get 100 rupees in 1 year's time. So it's presently we are in 2024. Let's suppose you're due to get 100 rupees in May of 2025. So how much you want to see, how much are these 100 rupees worth today? So you need to discount this, and with that you will be able to find out how much this money is worth today. So basically, if you want to define discounting, it's just calculating a sum to be invested now in order to receive a given sum in the future. So let's suppose you want to get 100 rupees after 1 year from now. So how much money should you be investing? How much money should you put in so that you're able to get 100 rupees 1 year from now? This is what discounting tells you. So the formula for discounting is that present value will be equal to the future value divided by 1 plus r, which is the rate of interest raised to the power n. So this is the formula that we use to discount anything, any cash flow that we want to bring to the present value. Then let's understand what are the reasons why money has a time value. So time value of money. There are primarily three reasons why there's a time value attached to money. Number one being the liquidity preference. Basically, this means that people prefer to have cash in their hands at the moment. This is why, to defer getting cash, they want some extra return. So that's why money loses its value with time. This is liquidity preference. Second is the risk. Let's suppose you have given a loan to someone. You're this person A. You have given a loan to someone named as person B, and you have loaned this money. Now you want some extra. Let's suppose you've given 100 rupees to him and he wants to return this money back to you after 5 years. Now 5 years is a big amount of time. There may be a possibility that this person runs away and never actually gives you your money back. So because you're taking a risk, you are also expecting something extra over and above what you are loaning to this person. So this is another reason why money has a time value. And then the third thing is inflation. So you all would have heard the classic example of, if you go out to buy a burger today, my drawing is pathetic. So let's suppose if you go out to buy a burger today, maybe that burger costs rupees 50 today. And if you go out, let's suppose 5 years from now, do you think you'll be able to buy the same burger for rupees 50? No, right? That's because of inflation. That's because there's a general rise in the price levels in an economy as time progresses. So these are the three reasons why money has a time value, why money loses its value with time. Now, before we move to the two or three discounted cash flow techniques which we have, let us first discuss what are the advantages of taking into account the time value of money when it comes to discounted cash flow techniques. So let us see the advantages of discounted cash flow techniques. Number one advantage is that they take into account, what all do they take into account? They take into account, number one, time value of money. They also take into account the timing of your cash flows. That means when exactly are your cash flows coming in. That is also very important. Then the third thing is that cash flows over entire life of the project are considered. Entire life of project. Another advantage is that they give you a more objective basis. More objective basis. Objective meaning that there's no scope for any bias for evaluating and selecting projects. So these are the advantages of your discounted cash flow techniques. Now let's move towards the disadvantages also. What could be the potential disadvantages of using DCF techniques? Number one is it is time consuming and complex. Basically, when you talk about discounted cash flow techniques, you're indirectly talking about NPV and IRR. So what are the disadvantages? That they are time consuming and complex to calculate. Another disadvantage when you have such NPV and IRR, what could be another disadvantage is that it will be difficult for you to explain it to people who do not belong to finance. So difficulty in explaining to non-financial managers. Let's talk about a few more disadvantages. Another one being that there's a complexity to estimate an appropriate discount rate. So complexity. So when you're calculating basically the NPV, you need a discount rate, right? So it's not always possible that you get the exact, or it's very difficult to estimate how much is the discount rate of that is appropriate for that company. Complexity to estimate an appropriate discount rate, and this is especially for unquoted, unlisted companies. Why? Because they do not have any market price of the shares that they have, so it's difficult to calculate the cost of capital for them, and hence to calculate an appropriate discount rate. Then number 4 being that the managers may feel little connection between their techniques and their actual performance or bonus systems. So the link between what the DCF tells them and what their performances and bonus systems look like may be, a weak connection. So managers may feel, managers may feel little connection between DCF techniques and their own reported performances and bonus systems. So these are a few disadvantages of your discounted cash flow techniques. Over here, like I told you earlier also, discounted cash flow techniques primarily refers to your NPV and IRR. Now, let's have a look at all of the techniques which we have been talking about. So if I talk about NPV first, so NPV, I'm sure you would have practiced a lot of full-fledged questions. This is just a revision that we're doing. So basically, if you want to define NPV, it's a theoretical change in the dollar value of a company due to taking that project. So this is how you can define NPV as. Also, another characteristic is that your NPV shows the change in shareholder wealth. Change in shareholder wealth as a result of taking the project. All right. Now let's talk about the decision rule which NPV has given. If your NPV is positive, then you accept the project. If your NPV is negative, then you reject the project. This is how the decision rule works for NPV. Then let's talk about IRR briefly. IRR basically stands for internal rate of return. It can also be called a discount rate at which your NPV is 0. Discount rate at which NPV is 0. Now, basically, this is nothing but an average annual percentage return from the project. Also, another thing being that this is the highest finance cost that can be accepted for a project. So basically, if my IRR is also 20% and my cost of capital is also 20%, my cost of capital, if it becomes greater than 20%, then the project becomes not worthwhile for me. So this is how you can interpret IRR. Now, when it comes to the decision rule, it's a simple decision rule to follow. Decision rule is that if your IRR is greater than the cost of capital, which means the return that you're getting is greater than the cost, then you accept the project. If it's the other way around, if your IRR is lesser than your cost of capital, then you reject the project. This is how the decision rule for IRR works. Now, there's one more thing when it comes to unconventional cash flows. Now, what happens is usually when it comes to calculating IRR, conventional projects, the regular projects will have an outflow that you have to do right in the initial time period, which is year zero. And then for the remainder of the years, two, three, four, you have money actually coming in. So these are positive figures and not money going out. So this is what you call a conventional project. But when it comes to unconventional projects, which means that there are multiple reversals. Let's suppose in the project that I'm doing right now, uh, in year zero, in year zero, I had money going out. In year one, money came in. Two, also money came in. But when it comes to third year, I actually had to pay out some money, probably some capital expenditure, probably some warranty claim, anything that I had to settle. So I had money going out rather than money coming in. Then in the fourth year, again, money coming in. In the fifth year, again, money coming in. And maybe in the sixth year, money again going out probably could be the cost of dismantling, probably restoring the site to the natural capacity like where we used it from. So this is what an unconventional project will look like. So basically IRR has this problem that whenever there are projects which have multiple cash reversals, IRR can give you multiple yields. IRR can give you multiple yields. Now, what does this mean is that you will get multiple answers. There will be two or three discount rates at which you will be getting the NPV as zero. So this is what you mean by the problem which is there with unconventional cash flows when it comes to IRR. So now that we have discussed about NPV and IRR, let's also draw a comparison between NPV and IRR. So let's try to see and compare them over a few factors. So number one thing is that NPV is an absolute measure. What do you mean by an absolute measure? That it tells you the exact increase that there's going to be in the wealth of the shareholders if a specific project is undertaken. Now, when it comes to the IRR, it's a relative measure. That means it gives you only a percentage. It does not tell you the exact amount by which the wealth of the shareholders is going to actually increase. Now, just recapitulating about the decision rule, if your NPV is greater than zero, then you accept. If your NPV is lesser than zero, then you reject the project. Then there was the decision rule that we also discussed for IRR, that if your IRR is greater than the cost of capital, then you actually accept the project. And if it's the other way around, that your IRR is lesser than the cost of capital, then you reject the project. This is how the decision rules work for both of the methods. And then another thing that you can talk about is that NPV shows the dollar change in shareholders' wealth, which is nothing but an extension of the first point, that it's an absolute measure. Now, when it comes to IRR, it does not show the absolute change in wealth. Another basis for comparison is about the number of solutions. So NPV is also always going to give you a unique solution. There's only going to be a one NPV at one discount rate. But when it comes to IRR, it may result in multiple solutions. And the last point over here will be that NPV is always reliable for decision making, but when you talk about IRR, it may not always be reliable. Why? Because again, it can give you inconsistent decision rules when it comes to, multiple projects with multiple cash reversals. So this is something that, your IRR is not always reliable. Now, with this, we have come to an end to this chapter. This was chapter number 4 for you guys. In the next video, we're going to be continuing with chapter number 5. I hope that this was helpful. Thank you for watching.